Okay, so this lesson is on combining functions and making a composite function, which basically a composite just means we are using the output of one function for the input of another. Remember, you will be able to use your notes on your assessment. So please make sure that at this point that you have a notebook or some way to take some notes for some examples that you can look at quickly. Remember, do not write everything down. Write down the things that you feel are going to help you to remember how to do the problems. And essentially, all this means is that we're going to be combining functions by adding them, finding the sums, subtracting them to get the difference, multiplying them to get products, and dividing them to get quotients. And we are also going to do something called the composition of two functions, which basically means just using one function output as the input of another function. And we'll go through some examples for you. So I think the most daunting thing about this topic is the notation. It looks a little scary if you're not familiar with it, but the idea is pretty simple. So if for example, if I'm finding the sum of two functions, we're going to put in parentheses f plus g of x. And that simply means that you find f of x and g of x, and then you add them together. And you can see over here we have an example. F of x equals the square root of x. G of x is x cubed. And so if I'm going to do f plus g of x, I'm going to just write the square root of x plus x cubed. My input was x. Same thing if you're subtracting, you're going to subtract them. If you're multiplying them, then you make the product. And if you're dividing them, then you would make a quotient. The g of x is on the bottom. So g of x is x cubed, so x cubed is on the bottom. Note this important thing about the domain. When you're dividing functions, you cannot evaluate things with 0 in the denominator because we're not allowed, of course, to divide by 0. So we make this extra little stipulation that x, we cannot have it equal to 0. So we write x is not 0. All right, in this example, we have two functions. One function named f is x cubed. So that means we take the input and we multiply it by itself 3 times. The other function is g, and for g, the instructions are that we subtract 9. So we take the input and we subtract 9. How do we add them, subtract them, multiply, and divide them? So let's go ahead and go through this. So the first function says f plus g of x. So we're going to take f of x and add it to g of x. And that means that our answer is going to be x cubed, because that's what f of x is, plus x minus 9. That's what g of x is. And so our answer is x cubed plus x minus 9. And we can't combine them any further. Remember, you can only combine like terms, so be careful to stop at that point. All right, so the next part B asks us to subtract them. So we're going to take f of x and we're going to subtract g of x. And so that means we're going to take x cubed. Now you have to be careful when you subtract here, because remember, we're subtracting g of x. G of x has 2 parts. We're going to subtract x, so that's going to be minus x. But we're also going to subtract this minus 9. And if we subtract a negative, it becomes a positive. So be very careful, because that's where you will make mistakes here. So we're going to write minus x, but it's going to be plus 9. And that's from minus 9 becomes the plus 9. So just make a note for yourself to be careful. Yeah, let's see. Be careful when you're subtracting a negative. All right. So the next example is when we're finding the product, and notice that the little multiplication sign is solid. If it is an open circle in the middle, it means composition, which is different, and we'll get to what that means later. But it has to be a solid dot to imply multiplication. So in this example, we're going to multiply the two parts. So we have f of x, and then we're going to multiply it by g of x. And so we have x cubed, and we're going to multiply it by x minus 9. So we will need parentheses because we have to distribute. That x cubed is going to be multiplied by both parts, the x and the minus 9. And so we're going to have x cubed times x, so that's x to the 4th power, minus 9x cubed. And so this is our answer to this. Oops. There we go. All right. The last part, the last example is the quotient. So I'm going to be dividing f of x. I'm going to divide by g of x. And f of x is x cubed, and g of x is x minus 9. Now, this is my answer. I can't simplify that at all, but we do have to look carefully at the denominator and say, okay, when would this be 0? Well, this is 0 when x is equal to 9, because 9 minus 9 is 0. So I have to make this extra step and say x is not equal to 9. And there we have it. Now, there are some extra examples in the folder where in Khan Academy, where they go through examples of adding, subtracting, multiplying, and dividing. If any of that is a little bit still scary to you, or you're having some trouble with it, please go watch the video of your choice that will help you to clarify that for you. All right, so here's an opportunity to try this yourself. The two functions are f of x equals x squared plus 3, and g of x equals 2x. And I would like you to stop the video, pause it. So pause the video, and then solve or do these 4 problems, and then restart the video to see the answer. So pause the video at this point. All right, so let's check our answers. So the first one is we're adding the two functions, f plus g of x. So f of x is x squared plus 3, g of x is 2x. So the answer would be x squared plus 3 plus 2x. Of course, you could put it in standard form. That would be just as correct. But either way, that would be the answer. The second one is f minus g of x. So f of x minus g of x. And here we don't have any negatives to worry about, but it would be x squared plus 3 minus 2x. And so x squared minus 2x plus 3 if I put it in standard form. So either one of those would be correct. The third one is the product. So I'm going to take f of x, which is x squared plus 3, and I'm going to multiply that by 2x. And so we need to distribute this 2x. So we're going to have 2x to the 3rd power, because x squared times x is x to the 3rd power, plus 6x. And so this would be the answer for that one. And I'm going to move the quotient to the bottom here where I have room. And so we have f of x divided by g of x. And so that's going to be x squared plus 3 divided by 2x. And of course, as we stated before, I have to look at that denominator and make sure that it's not 0. When would that be 0? Well, 2 times 0 is 0. So I will write x is not equal to 0. So I hope you did well on those. Remember, there are some further examples on Khan Academy that I have posted links in your folder for. All right, so this is an application problem, and I'm just going to read through it first, and then we will talk about the parts because we have to discuss some definitions here. So the demand for a certain electronic component is given by P of X equals 1,000 minus 2X. Producing and selling X components involves a monthly fixed cost of $1,999 and a production cost of $4 for each component. And what they're going to ask us to do is write the equations that model revenue, the amount of money coming into the company, and the total cost, the amount of money going out. So first of all, let's talk about the demand. So demand is a function that economists use that connects the price of something to how many units are produced and sold. And so this demand P of X, they used P for a reason. It's going to be the selling price that somebody is going to be selling this, or this company is going to be selling this component at. And so the revenue, the money coming in, is going to amount to this price times however many units they make and sell. So we can write our revenue function as R of X is going to be this P of X times X. So it's the revenue is how many things that they produce and sell. Notice it's a small p, not a capital P. Remember, we use a capital P for profit. In this case, they're using a small p. So small p of X times X. And in this case, we can write that as 1,000 minus 2X and then times X. And so that would be 1,000X minus 2X squared. That would be our revenue. Then it asks us also, it's going to ask us to write a cost function. And what would the cost function look like? So let's talk about cost. There's two parts to cost. One is the fixed cost, and fixed cost is something that does not change based on how many things you make in that company. So, for example, a fixed cost might be something like the rent you pay. You know, if I'm paying a monthly rent of $1,000 for my building, then whether I make two little electronic component chips or if I make 1,000 of them, it's not going to change the amount of money I pay for my rent. That is a fixed cost. And there are other fixed costs, and I'm sure if you think about it, you can think of a few others. The cost per component might be the ingredients that you need to use to produce your component. So maybe the plastic, the anything that you're going to use, the packaging, anything that goes into that component that you're going to sell. And so it costs $4 for that variable cost, but that's going to go up every time you make another unit, because the more units you make, the more cost is involved in this particular area. So what would that look like? Well, the total cost, the cost function, C of X, is going to be those two pieces put together. So it's $4 per every unit. I'm making X units, so it's going to be 4X. And then I'm going to have my fixed cost, which is 1,999. So this is the cost function, 4X plus 1,999. So we have our revenue and our cost. So now they would also like us to identify the profit of this function. And remember, profit is defined as your revenue, your money coming in, minus your costs going out. So it's your extra money. So in this case, we're going to take our P, capital P of X, and it's going to be equal to our revenue, the money coming into our business, minus C of X, which is the costs that it takes to run our business, and that's going to be our extra money. So we're going to have 1,000X minus 2X squared. That's our revenue. And we're going to subtract from that 4X. So notice we have minus 4X. And then we also have to subtract 1,999. Remember, both of these are going to become negative because I'm subtracting the entire thing. If you make a mistake at this, most likely it's going to be a sign error. So I'm going to write minus 1,999. And so since I ran out of room, I'm going to rewrite this a little bit. I'm going to write, and maybe I'll write it in standard form. I'll write minus 2x squared. 1,000x minus 4x is going to give us positive 996x, and then minus 1999. And so this would be our profit function. So the last question involving this context or this situation is to find the maximum monthly profit. So we have our equation, so we can either use our graph and do it graphically using technology, or we could just calculate it. So remember, our graph is going to look something like this. Okay, it's a concave down parabola for this quadratic profit function, and our maximum profit would be right here. So this is X is the number of units that we produce and sell, and this is be our profit on the y-axis. So using our calculators, we could determine that. We could also find the axis of symmetry because that is where this maximum profit occurs. And so taking X equals negative 996 over 2 times negative 2, using the formula X equals negative B over 2A, that will calculate to 249. So you would see that same thing graphically, that our maximum profit is going to occur when we produce and sell 249 units. And to find that maximum profit, we have to substitute it in, or again, use our graphing calculator functions to find it. So P of 249, if we evaluate it at the input of 249, we get $122,003. And so that would be our maximum monthly profit. So again, think about how that would be useful. Well, it would give you a goal that we want to make at 249 units. And so I would know how much materials to bring into my company, and I would know how many I would want to tell my salesman to make sure that we sell. So the last big idea we're going to talk about is the idea of a composite function. And it looks, in some ways, it looks similar, the notation, to finding the product of two functions. But I'm just going to write down the notation for a product, and so you can compare them. So up above here, I've written f times g of x, the product of the product of f of x and g of x. Down below, you see the composite function of f of g of x, and you can see that it's written with an open circle. I believe that's because we say that this is f of g of x. I don't know that that's necessarily true, but I'm imagining that open circle came from the O of. So they write f of g of x like that. So it's very important that you pay attention to that detail, because if it's a solid dot, you're going to be multiplying those two functions. But if it's open like this, we do something entirely different. And what that different thing is that we take and we find g of x, and then we use g of x for the input of function f. That's all it means. And so sometimes you will see it written like this, f of g of x. And it still means the same thing. You're going to do g of x, and then after you do g of x, then you're going to do f of x. And f of the output of g of x. So it's easier to see once we do a couple examples. So here we have three functions. We have f of x, which the instructions tell us take your input x, triple it, and then subtract 1. G of x, which says take your input and square it and subtract it from 4. H of x says that we're going to take the number 1 and divide it by my input. And here it's asking us to find h of f of x. Notice again, it's written in both ways. Normally for any particular problem, it's written one way or the other, but here they're giving it to both notations. So this means we're going to do f of x first. So we're going to take x, we're going to put it through the function machine f, and what's going to come out is we have to triple x and then subtract 1. Then this output here, this 3x minus 1, is going to be the input that goes into h. So this is going to go into function h, and h says that we're going to take the number 1 and divide by the input. And so we're going to take that and we're going to say 1 divided by 3x minus 1. And so this is our final answer. 1 divided by 3x minus 1 is equal to the h of f of x. But there's one key part. Notice that I have a quotient here, so I'm dividing by 3x minus 1. I know that bottom denominator cannot be equal to 0, so I have to check and make sure that I know where that would happen. So where would that be 0? It would be 0 when 3x minus 1 is equal to 0. And so that's what we're going to look into here. We're going to say, when is 3x minus 1 equal to 0? Well, if you can't see it for yourself, it would be when x is equal to 1/3. But we can solve this. We have 3x is equal to 1, divide by 3, x equals 1/3. And so this cannot happen, because if 3x minus 1 is 0, we're dividing by 0. So we have to say x is not equal to 1/3. And this would be our answer. So here we have our three functions. And again, the function instructions for f say that we're going to triple our input and then subtract 1. The instructions for g say take the number 4 and subtract your input squared. And the function h says we're going to take the number 1 and divide by our input. And here we want to find f of g of x. So we're going to do g of x first, and then we're going to apply f to our next set of instructions. So my input is x, and if my input is x, then I'm going to do g to it first. And g says that we're going to take the number 4, and we're going to subtract my input squared. So 4 minus x squared is my output there for doing g to x. And then we're going to apply the next function, which is f. And f says we're going to triple it. So we take the output that I had from the last part, and I'm going to triple that and then subtract 1. So I need to take and multiply 3 by 4 minus x squared. That was the output from g, and then I'm going to subtract 1. So simplifying this, we have 12 minus 3x squared minus 1. And so this is going to be 11 subtract 3x squared. And that will be our final answer. 11 minus 3x squared would be the f of g of x. All right, so for the example. So here we have three functions, f, g, and h. And let's take a minute to go through each of them and look at the function instructions. So if we're doing function f, the instructions say we're going to triple our input, multiply it by 3, and then subtract 1. If we're going to use function g, we're going to square our input, multiply it by itself, and then subtract it from 4. When we're doing function h, the instructions for function h say take the number 1 and divide by whatever your input is. So here it's asking us to do these this g composition f, so g of f of x. They've written in both notations. Normally it's only written one way or the other in any particular problem, but I suppose we're doing that to emphasize that it's the same thing. So this says we're going to do f of x first, and then once we have f of x done, we're going to do g to it. So the first set of instructions is f. So I'm going to take x, it's going to go into f, and f says we're going to triple it, so it's going to be 3x, and then subtract 1. So that's the output. Then we're going to do G. So then this is going into G, and G says that we're going to square our output and then subtract it from 4. So we're going to take the output from the first function, which is 3x minus 1. We're going to square it and subtract it from 4. So we're going to take 4 and we're going to subtract 3x minus 1 squared. So we're going to simplify this. This is 4 subtract 9x squared minus 6x plus 1. And so our final answer here is going to be 4, well, not our final answer, 4 minus 9x squared plus 6x and minus 1. And then the 4 and the minus 1 can be combined. So our answer is going to be minus 9x squared plus 6x, and then 4 minus 1 will give us positive 3. So this would be the final simplified answer.